Okay, so in this video, in chapter 3, we're going to talk about matter and energy, and in this video specifically, we're going to define matter, atoms, and molecules, and then we'll learn how to classify matter as a solid, liquid, or gas. So remember, everything around you is made of chemicals, so everything you see, feel, touch, and sense is made up of matter. Matter makes up our chemicals, so there are many different kinds of matter. So all the chemical elements, and then therefore all of the molecules that those atoms make up. And so to be more precise, matter is anything that occupies space, so it has volume and it has mass. So anything that has volume and mass is matter. You matter. You are matter. Hey. So again, that might be extremely large items like planets or really, really small particles like air, dust, or even those submicroscopic particles that we can't see. So that's all what matter is. So matter is composed of atoms that make up molecules that really build to what we see in the universe. So matter is anything that has volume and takes up space, or has volume and has matter. Takes up space and volume, the same thing. So has volume, has matter. They're made up of atoms. So what is an atom? It's a submicroscopic particle, so it's too small to be seen from a regular microscope. And those particles are the building blocks of the universe. So it's kind of the smallest grouping of stuff that we can categorize. So we can tell all of the different atoms apart from each other. So smallest building blocks of the universe, all matter is composed of atoms. So sometimes it's just a pure sample of substance, like you might have just a pure iron nail. Or sometimes they're bonded together to form molecules, like a water molecule, for example. So that being said, molecules are two or more atoms that are joined together in a specific geometric arrangement. So they're more complex than atoms. We've got lots of different atoms joined together. And we're talking about atoms being joined together. We're going to go ahead and call that a chemical bond. Eventually, we'll have a more precise definition of chemical bonds. We'll talk about types of chemical bonds. But for right now, let's just think of it as the thing that joins two atoms together in a molecule. And so there are many different classifications of atoms and molecules, and all of these different classifications of how we classify atoms and molecules are going to be how chemistry is studied. Is basically like, okay, we're going to take matter, categorize it this way, and it's that kind of chemistry. We're going to take matter, we're going to categorize it that way, it's going to be that kind of chemistry. So in the end, we can really kind of break it down to some of this stuff. So while I said that with like kind of a regular microscope that we might use in the lab, we can't see atoms. However, we do have scanning tunnel microscopes that allow us to see them. So on the left here, we have a picture of some nickel atoms, and then on the right, we can see the double helix of a DNA molecule. Okay, so matter is stuff. It has volume and it has mass. What do we do with it? So let's talk about the common states of matter. So we'll talk about all four, then we'll talk about the three we're going to use most often. So often scientists deal with classification to tell different things apart. Humans love to categorize things. We love to look for patterns. We love to find things where we can group them together, look at similarities, look at differences. So in this class, we'll talk about how to classify matter by the state of matter and then by the type of matter that it is. So first and foremost here, again, we're going to talk about the states of matter. So that means matter exists in 4 different states, okay? Solid, liquid, gas, and plasma. However, in this class, we're only going to talk about solids, liquids, and gases. So those are the only 3 you're responsible for. We tend to leave the plasma for the physicists. We're going to define the states of matter by how the atoms or molecules, those particles, are interacting with each other and how much freedom they really have for movement. So for example, let's take a look at solids. So solids are atoms and molecules that are packed in closely together in fixed locations. So as we talk about solids, liquids, and gases, I'll give you an example for water. So water's solid form we call ice, right? So ice in your drink, that's solid water. Solid water. So the atoms and molecules, they were closely packed together in fixed locations. So you can kind of see in my picture over here labeled A, I have all of these molecules or all of these atoms lined up here. They're in a rigid structure and they stay there. So They might have a little bit of freedom to motion where they can kind of wiggle in their chair like this. They're not going out of their space. I'm staying in my little zone, but I might wiggle just a little bit. So that is like about all the motion that happens in a solid. It's just a little bit of wiggle of our particles. So it's a rigid shape, it's a rigid structure. They're interacting with each other, all of those atoms and molecules are, but they're not free to move outside of the structure. They're not going anywhere. They're just shimmying. So remember, solids are also a rigid shape that doesn't change no matter the container. So if I had a cube of ice and I put it in my coffee cup, and then I put it in a wine glass, and then I put it in a big old popcorn bowl, we're not going to see any difference in the cube of ice. It's going to look like the same solid shape of ice from container to container. So we might also talk about liquids in contrast. So solid, we're going to move to liquid. So liquids are atoms and molecules that are still closely packed together, but these atoms and molecules can kind of slip and slide past each other. They don't have a space where they're supposed to be. They're just kind of moving around, loosey-goosey. So water's liquid form is, drumroll please, water. So we call liquid water water. So the atoms and molecules, they're still touching and interacting when they're like this. They're just able to move past each other. They don't have a rigid structure, but they're kind of held in place by that. So you can see that it's kind of chaos down here. There are lots of different places those particles could be. There's not very much space in between them, but they're still interacting with each other and they're still slipping and sliding past each other. So liquids, again, take the shape of the container. So our ice cube, if we put it in those 3 different containers, we couldn't tell the difference. However, if I have a little bit of water in my coffee cup, if I pour it in the wine glass, it's going to take the shape of the bottom of the wine glass. If I pour it from my wine glass into my big old popcorn bowl, I would see that it'd take just the bottom of the popcorn bowl. So it's just kind of a general idea there. But, the water doesn't expand to fill the container. So it doesn't, go from the bottom of the bowl to the top of the bowl if I only have this much. It doesn't expand its way up. It still sits in the bottom of the bowl. So it takes the shape of the container, but it doesn't expand to fill. So solids, you got the rigid structure. You can only wiggle in your little space. Liquids, you're loosey-goosey. You can move out and around. You're still interacting. You're still touching and stuff, but we can move around. We can go different places, kind of a deal. So let's talk about our third state of matter, gases. So gases are atoms and molecules that are separated by a large distance that do not interact with each other. So we might picture gases as doing something like this. My 2 fists, they're not doing anything that has anything to do with the other. They're just floating around doing stuff. So we're not going to consider them to have any significant interactions. Maybe if they passed by each other or something, but we'll just let it go because it's not going to be strong enough for us to care. So they're free to move however they wish because they're not tied down. They're not influenced by any other atoms and molecules. And then gases also expand to fill the shape of their container, right? So if I have a small amount of gas, I can't just put, if I put the lid on my container, I'm not going to have an air sample that collects at the bottom of my container. I'm going to have those air molecules bouncing around in my entire container. So gases can expand and contract depending upon where you put them. And we call this characteristic compressibility. So a substance is compressible if you can remove the space between the atoms and molecules. So remember, we're starting with gas molecules really far apart, and when we compress them, we're kind of making them do this. So they don't have as far to go. They're still not interacting with each other. They can run around and run past each other. But we went from having a big wild space to, okay, I've compressed my gas where it only can move like this instead or something. So you can push those gas molecules in towards each other before they're forced to interact, but once we push them in tight enough, they're interacting, they'll become a liquid or a solid from there. So solids and liquids are not compressible. Gases are compressible. So we can go ahead and compare solids and liquids and gases as well. So comparing solids, liquids, and gases has us looking at something like this. So again, we can see that a solid can only just vibrate around a fixed point. A liquid is free to move around, and a gas are free to move around relative to one another. And a gas is going to be free to move around no matter what. When we're looking at just kind of how far apart those particles are. In a solid, they're really close together. In a liquid, they're really close together. And then in a gas, remember, they're really far apart in comparison. So when we're talking about shape and volume, that means that this is our rigid shape. So when we take our ice cube different places, it doesn't change its shape. And then when we, but liquids and gases can change their shape. Whereas when we're talking about volume, that's our kind of idea of compressibility. So if it has a definite volume, it is incompressible. So it has a known volume. So your solid, you don't change the volume of. Your liquid, you don't change the volume of. But if you have a gas, you can have different volumes of the same amount of gas. So that's, again, that ability to be compressible. So that's a little bit about how to classify solids, liquids, and gases, and talked a little bit about matter and then how to categorize that matter here. So that's it.